All right, this is Honors Algebra 2 Pre-Calc. We're doing 6.3 in Algebra 2, and this is our third video. We're going to talk a little bit about the domain and range of logs. So this has already been addressed a bit, but let's just review anyway. So recall that exponentials, like f of x equals b to the x, have a domain of all real numbers, so negative infinity to infinity, and a range of essentially only the positive numbers, meaning 0 is not included, so starting greater than 0, right? Thus, when we do the inverse function, the log base b of x, the domain and range are switched. So the domain is all positive real numbers, so 0 is not included. It's numbers greater than 0. And then the range is negative infinity to infinity, all real numbers. So the short version here is that to say only positives inside logs, which is one of the big 4 domain restrictions that I mentioned all the way back in chapter 2 when we learned these, and I said, hey, you don't know logs yet, but let's just go ahead and throw these out there since these are the big 4 domain restrictions forever and always. Right? So here are the big 4 domain restrictions. So now you know enough to do all 4 of them. So number 1, you can't divide by 0. So if there's a denominator, you set it not equal to 0, and then solve for x. That's your domain restriction. Number 2, no negatives inside even roots. That's called the radicand, which is the inside of the root, is greater than or equal to 0. So just to be clear, radicand is a real word, right? This thing is called a radical, right? And the thing on the inside of it is called the radicand. All right, and later, when you get to calculus, we're going to learn about integrals, and the thing inside an integral is called the integrand. Anyway, so no negatives inside even roots. You set the radicand greater than or equal to 0 and solve for x for your domain. Now 3, this is the one that we just learned enough to do, only positives inside logs. So the inside of the log is strictly greater than 0, and then you solve for x. And then we talked about 4 previously in other sections. It's just real world constraints, right? Like if your problem is a word problem, there are logical restrictions that happen. For instance, if x is age in years, you can't have a negative age, right? If x were to represent, I don't know, let's say x represents shoe size. You can't have somebody with a 157 million shoe size, right? So like there's definitely restraints based on real world constraints. Okay, moving on. So we're going to find the domain of each function. These are all logs, right? So remember that with logs, right, the inside of the log, right, the inside of the log has to be strictly greater than 0. That's the rule. Okay, the inside of the log has to be strictly greater than 0. So in this case, the inside of the log is just x. So the domain of this function is just that the inside of the log is greater than 0, no math required. But for the second one, the inside of the log is a 5 minus x, which has to be greater than 0. Oh, so the other way to write x is greater than 0, by the way, would be to write 0 to infinity with parentheses on both ends, right? If I solve this for x, I have negative x is greater than negative 5. When I divide by the negative, it flips the direction of the sign, and I get x is less than 5. So I could either write my domain as x is less than 5, or the other way to write that would be negative infinity up to 5, but notice the parenthesis, not the bracket. The last one's a little bit trickier. Now I need this inside thing, right, this x squared plus x minus 2 to be greater than 0. Well, this is something that we learned to do at the end of chapter 5, right? So this is where we learned quadratic inequalities. So the trick is that we're going to pretend it's an equation, right? We're going to pretend it's an equation, not an inequality. We're going to say, hey, if this were an equation, what would those zeros be, right? This factors into an x plus 2 and an x minus 1, meaning that the 2 zeros would be when x is negative 2 or when x is a positive 1, right? I said each factor equal to 0. If I look at what this is, right, this is a smile. It's a quadratic equation with a positive in front of the x squared. So if the zeros are at negative 2 and 1, the smile looks like this. I want the windows where this thing is physically positive, which are here and here. So the domain of this function is going to be negative infinity to negative 2, parenthesis, and then from 1 to infinity. The other way to write that would be x is less than negative 2 or x is greater than 1, right? Not and, because not both of them are true, right? I would suggest that you use parenthetical notation. In my humble opinion, it is literally always better. You could have also done this by making the more detailed sign charts that we saw in 5.8. But one of the points I want to make here is that at no point in this question in E5 it was a sign chart mentioned or anything else. Quadratics weren't mentioned, but you have to look at that E5C and say, oh, that's a situation where I need to find the zeros of this quadratic and then figure out where the quadratic's positive, which requires either this kind of visual sign chart or the other kind of sign chart that we've seen that looks like this, which also would have gotten you the same answer, right? You'd list your factors, and I promise that you get the same answer. So, so your function is positive and then negative and then positive, which as you'll see is the same answer I got the other direction. All right, so let's try a P5 and then that'll be it for this particular video. Go ahead and pause me if you want. So again, we're finding the domain of each function. The inside of the log has to be greater than 0. So here, this is just x is greater than 0. I'm going to write the domain as 0 to infinity, parentheses on both ends. The inside of the log has to be greater than 0. So 2x plus 8 is greater than 0. 2x is greater than negative 8, x is greater than negative 4. So that's going to be from negative 4, again with a parenthesis, not a bracket, to infinity. And then this one's the tricky one because it's a quadratic, so I need to know when x squared minus 7x plus 12 is greater than 0. Well, if I pretend it's an equation, right, if I pretend that this is an equation, I want to know when x minus 3 times x minus 4 is equal to 0. Well, it turns out that those two roots are 3 and 4. Once you know that, again, this is a smile because of the positive in front of the x squared. So it's going to look like this. This is 3, this is 4, so my winner are these two sides. So I'm going to get that the domain is negative infinity to 3, and again, from 4 to infinity. And you could have done that with the other kind of sign chart as well. And that is it for 6.3.